2 days in a week from me? I don't understand. Okay, so I have already put the problem set up here. Right. Oh, yes. Yes, this is it. Okay, so I'm going to skip the true false section. I will hit the highlights on the ones that I think are like part of the most difficult first, and then I'll take some questions from you guys because I hope to answer some of your questions as we go. And if you're like, oh my gosh, I totally know this, I don't need your help anymore, Miss Inlo, then go ahead and keep doing that Quizlet because there's some extra practice there for you just in case. All right, so first thing you see, I want to walk through the process. What's the very first thing you do when you look at a formula? Decide on if it's what or what. Ionic or covalent. Can you do that right now? What is it? It is ionic. Everyone should have a periodic table out because you probably don't have that baby memorized, nor do I. So this is ionic. So the very first thing you're doing is I'm just going to go ahead and label if this is ionic or covalent so that I remember my two different ways of naming. So I see it's ionic. If it's ionic, guess what, guys? It has ions. You have to go find the ion charges. Find the ion charges. Barium has a what charge? +2. It's in group 2. Lose 2 valence electrons. Sulfate. Is that a complex ion or is that just plain old nonmetal? Complex, right? It's a polyatomic ion. Don't look at your polyatomic ion list right now. Shout it out. Or here. What's the charge? SO4 2 minus, right? And if I'm a polyatomic ion, I better have some parentheses around me because if you crisscross these charges and there's not a parentheses, sometimes the number gets really big. So if I were to crisscross these charges, that 2 would go down here and it would look like 42, correct? And that's a big fat lie. So it's actually put a parentheses around all your polys, and that will help you pretty much forever. You can also adjust my formulas to have parentheses so it looks as if it's something that you remember, like a polyatomic ion. So Ba2, SO4 2, I'm just going to kind of work across the board here. We know that the 2's and 2's are then need to be reduced to the empirical formula, meaning the simplest ratio. So then we change that to BaSO4. And you can keep your parentheses or not at this point, and I'll keep it there just in case you'd like to see. There's a first name and there's a last name. Barium sulfate. All right, who knew BaSO4 was sulfate? I mean, sorry, SO4 2 minus was sulfate. Okay, so if all you guys know that sulfate, what's sulfite? SO3. How did I know to do that? Right, because anytime you change the polyatomic ending from 8 to ite, you do drop an oxygen off. The charge stays the same. That's why you should memorize the 8s. The ites kind of fall into place if you know that system. Okay, aluminum oxide. First off, identify ionic or covalent. Ionic. Okay, I'm going to do a couple of these out loud with you, and then I'll start asking for your help, okay? So this one's definitely ionic. If it's ionic, you must find ion charges. Right, so aluminum. What is the charge of aluminum? Find on your periodic table. 3+. Thank you, EJ. Okay, oxide. I'd rather use a periodic table, wouldn't you, than memorize polyatomic ions? Okay, so ides are easy. Ides are straight off the periodic table. What is oxide? Oxygen with a charge of 2 minus. Okay, so then you crisscross your charges, and what do you get? Beautiful, people, beautiful. And I haven't done this part up here, BIBMT. I'll do that in a second. Okay, silicon dioxide. What's that di screaming at you? It is covalent, right? If you see that prefix, that should tell you that prefix is indicating the system, this nomenclature system. This is a covalent compound. Because silicon, this is what Nick said, it's in that weird place on the periodic table. You're like, is it acting as a metal or is it acting as a nonmetal? It's that metalloid. So sometimes the formula is going to help you with that. So silicon dioxide. Don't even look at the periodic table. Write down what you hear. Silicon dioxide. O2. Silicon dioxide. Done. Is the prefix one. You don't need to find ions because it's a covalent compound. Okay, now I'm getting to like first name, middle initial, last name. Lead-3 sulfate. Lead symbol is what? Pb. Okay, so that's a metal or non-metal? Metal says what kind of compound? Ionic compound. Okay. So ionic compounds, you must find their charges. So if you go look for lead on the periodic table, where's it at? So it's at that post-transition metal group, right? So post-transition metal, wherever you're kind of on the left side of the periodic, or the right side of the periodic table. So that to you, you're like, I don't know, what's the charge? Well, you don't have to look at the periodic table for the charge because these transition metals have their charges built in to their formula. This 3 refers to lead's charge. So we're going to say lead 3 plus Sulfate, again, is polyatomic or simple? It's a polyatomic. So that 8 ending is telling you they're polyatomics. SO4, and the 2 minus is the charge. So crisscross, what do you get? PB2, SO4, 3. Give me a thumbs up if you got that one. Okay. Now, I'm going to stop for a moment. There's some acids here. On this one, on this little section, I think there's probably like 15 questions here. I'm going to go ahead and take some questions from you guys on where you struggled. Go ahead, Caroline. Say the name for me.
You mean on this slide?
On this particular, section. I'm going to get questions before I move on.
No acids.
Okay, yeah, I want to do acids momentarily. Yeah.
So what would you do for bisulfate?
Okay, so this is that weird one, right? Because when you hear bi, you're thinking 2, right? But this was where, you know the system on how the polyatomic ions change based on like how they're said, you know what to do. So 8s, they have a specific number of oxygens, yes? When you hear ite, you know the drop in oxygen. The charge stays the same, everything else stays the same. Well, when you have a polyatomic ion and it has a bi in the front, it means take this guy, which is sulfate, I'm going to write that down here, SO4, 2 minus, and the bi actually means add an H plus. Why? I don't know, but that is what it means. It means add an H plus. H plus is a 1 plus charge. So bi means add an H plus. So when these two guys come together, they make a new polyatomic ion, which is just a really just a smushed together combination of these. So then I get H, SO4, but this 2 minus and 1 plus come together to make what? 1 minus. So this, guys, is bisulfate. Okay, so then this is the polyatomic ion you combine with sodium, and so that sodium is in group 1, it has a charge of +1. Bisulfate has SO4, HSO4, 1 minus. Crisscross, what do you get? AHSO4. Sodium bisulfate. Yeah.
The same for every polyatomic ion and bi, you add H.
And that's the system. That's you knowing how to use that system. It's only for polyatomic ions when you see the bi there. It doesn't say bi anywhere else, because every other thing wants to say 2 instead of saying bi. It says, how do you say 2 as a prefix? Di. Okay, so people would mix di and bi up. Darcy.
What's the difference between U and V?
Getting ready to go over that in a second. I'm going to go over names first there. Maddie.
If I kept the parentheses, would it matter?
Oh, no, it's totally fine. Like, I like to keep them for the beginning parts of our chem life together because then it helps you see the first name, last name easier. But you'll see on my stuff, sometimes it's more simplified without parentheses. So more questions here? Okay, let me go to the BM, BI, and T. So if you look at this compound, look at this one. How many elements do you see here? 3 types of elements, B, A, S, and O. That is ternary because it has more than 2 types of elements involved. So that's like a T for ternary. How many element types do you see here? 2. Okay, so 2 is a binary compound, meaning two elements involved, like binary code. What's binary code? 0, 1, 0, 1, 0, 1. So all those those 2 versions of numbers. So this is binary, but then your job is to tell me, is it binary ionic because it's an ionic compound, or is it binary molecular because it's a covalent compound? Binary ionic because it's an ionic compound. This one, however, SiO2, how many types of elements are here? 2, so it's definitely binary. Is it binary ionic or binary molecular? Why molecular? Because it's not it's covalent, right? Molecules and covalent, those are one and the same. Does that answer that for you, Darcy? Okay. Moving on to the next section. If you're good there, I'm good here. On this one, ammonium phosphate, I'm going to do the couple that I think are important. All of them are important, but, you know, the hard ones. Ammonium is that one polyatomic ion that is the cation, it's a positive charge. That's NH4, 1 plus. So if you already have the charge for this one, you must find the charge for this one. What's phosphate? I hear PO4 charge 3 minus, right. So I'm going to put parentheses around both of these. This 3 crosses down here, this 1 crosses down here. What's the overall? NH4, PO4, 1, right? So NH4 parentheses 1, PO4 parentheses 1, or NH4, PO4. I'm sorry, I forgot the 3 here. I was like, that just doesn't sound right. So didn't cross my 3 down. Sorry. NH4. Make these boards a little shorter for me. NH4 3, PO4 1. And you can put the parentheses there if you want to, if it makes you feel better, but you don't have to. Alright, so then there's some acids. How about barium bromate? Is bromate on your polyatomic ion list? Okay, so there's a system of things that really look quite similar. Can you guys tell me chlorate? What's chlorate? Not all at once. ClO3 charge, 1 minus. Okay, what's iodate? IO3, 1 minus. Okay, so chlorate has chlorine. Iodate has iodine. Bromate has bromine, right? BrO3, 1 minus, right? So if you know this one, you know this one, and you know this one because they all have the same style. Because they're all the halogens, right? The halogens are group 7A. Group 7A is fluorine, bromine, and iodine. And since they all have similar valence electrons, they also act very similar in the polyatomic ion formation as well. Yeah.
Does that apply to all groups?
No, it does not. Just these. Those are the ones that are similar. Okay, so where am I at? Barium bromate. Is this one ionic or covalent? Ionic, right? It is ionic because it has barium in the front. Barium's charge is 2+. Bromate is bro, like BRO. BRO3, charge 1 minus. Crisscross, what do you get? BA, parentheses, BRO3, parentheses, 2. Okay, on this list here, in particular, can I go ahead and take some questions? I want to hear your guys' questions because I don't know where you're struggling here. If you don't ask questions, you don't get answers, right? So, help me out here. Thank you, Nick. Gold to phosphide. Okay, so gold is a metal. We all know it's a metal, right? But it happens to be a transition metal, so it has a transitional charge. So I tell you the charge by showing you this, right? So I'm telling you gold, which is AU, has a charge of 2+. So if you find the first one's charge, it's an ionic compound. You have to find the second one's charge. Phosphide has the ending of I. The ides are the easy ones. Ides are picked straight off the periodic table, no polyatomic ion craziness involved. So what's phosphide sound like? Phosphorus. You go find phosphorus. What is the charge of phosphorus based on its location? 3 minuses in group 5, right? So AU, P, 3 minus, crisscross, what do you get? AU3, because that 3 crosses down, and the 2 crosses over, P2. AU3, P2. Okay? Can I get a question? Yeah, thank you, Jillian.
So the number you have transition level, will always be
Always is like 95% of the time, right? There are 3 transition metals that have a standard charge that don't have that variability. So if they have a standard charge, you memorize it just like you know the other ones. The other ones are easy because they're in these special groups. But like, for example, did I see zinc? I did not see zinc. I saw zinc on the last one. So zinc. Zinc is a transition metal, right? There is no Roman numeral after it. You must memorize zinc's charge. The other ones have the, the representative metals have 1+, 2+, 3+, and so forth. But zinc doesn't have a variable charge like a transition metal normally does. And I remember it by saying Z looks like a number 2, okay? So Z looks like a 2, right? So zinc's charge is 2+. What is acetate? Caleb, what's acetate? This one I'll give you a hint. It has 3 syllables. Acetate has 3 letters.
C2, H4, and O2.
H3, I got you. O2, charge?
Negative.
-1, right? -1. So zinc 2+, acetate, 3 letters is the only one 3 letters like that. 1 minus charge, create that by crisscrossing the charges, and you get Zn C2H3O2 2. So that's a good question, Jillian. If it's a transition model, most of the time it does have a number afterwards. I mean, a Roman numeral. Darcy, you have a question? Cool. Okay. Emily. Calcium hydride. Thank you. I knew the hydride one, right, would be the one. So, Kyle, can you help me out there? Tell me the process.
You find what's the charge of calcium.
Okay, group 2, right?
Yep, so 2 plus.
And it should take you about 3 nanoseconds to find these elements now. You guys have seen that periodic table for like a month. So know where your things are so you're not hunting forever. All right, keep going.
And then hydride is hydrogen.
Mm-hmm.
But since it can either gain one or lose one within octet, you have to figure out which one it is. So here it's the anion, so it loses one.
Great. So this hydrogen here, we know has one valence electron. And it can go up to helium's noble gas electron configuration, which is 2 electrons, which is why hydrogen can only attain duet, which we say it's the octet rule, but we know hydrogen is that one teeny, teeny, tiny one. So it gets a 1 minus charge when it goes up to helium's noble gas electron configuration. So Ca2, H1 minus, what's the overall?
The Ca and then
H2. Thank you. Please, please, please ask questions. This is like an open environment. Make sure you're asking for clarification. I'm going back to this one now. Anything else here? Yeah, Emily. Oh, the acid one? I'm going to wait on acids. Yep. Yeah.
So I noticed at the beginning they'll have the upper number,
The superscript?
yeah, the superscript, but the actual answer wouldn't have a superscript.
Absolutely, and that's a big, big point. On your final answer, you shall never have a superscript. Because those are charges, right? The charges have to be complemented with another one. They have to be crisscrossed down to represent the true ionic formula. And that's what people will do on their test. They'll leave some charges, like they'll cross one, forget to cross the other. It's not complete, so it's not right. Good point. Darcy. Okay, and not on this section. I'm going to the next section in just a second. Can I get any more questions here? Okay, yeah.
We're gonna eventually just memorize all the.
I'm going to say all of them hesitantly, because if you know the 8s, you already know all the ites, but then there's some random ones that don't have an ite. So like permanganate, what's permanganate? An MnO4 charge? 1 minus. What's carbonate? CO3. 2 minus. What's chromate? CrO4. 2 minus. Okay, so some of these you guys are gonna be using them a lot here. You're really gonna be using them really heavily for the next month. So that's why it makes you an efficient person. You know your stuff, and then you understand how the polyatomic ions are put together when you know their formulas. All right, let me do one that I haven't done one yet. Nitrogen monoxide. Scream it for me. Ionic or covalent? Covalent, right? That one's, you read it, you write it, there's no charges, there's nothing crazy. Don't look at the periodic table. So what do you see? N, and then you see 1 oxygen, right? Monoxide. That's it. Okay, let's go down here. I think, Darcy, is this where you started to have questions? Was it here? Okay, I'm going to go ahead and ask you to tell me that question. Oh, okay. So if this is just a definition. Formula unit goes with anything that's ionic. Instead of calling an ionic compound a molecule, it's totally not a molecule, so we have to have another name for it. Molecule goes with covalent. Formula unit goes with ionic. It just simply means it's ionic. That's it. Okay, let me go ahead to this page here. I know I already saw some wrong answers on this one, so here we go. This right here, FeO3. You know Fe is iron, right? So then you start writing iron. And then you're like, oh, iron's a transition metal. I need to give me its charge. Now, it looks as if Fe had this 3 charge, because when you uncrisscross, you bring the subscripts back to where they were, 3 plus, and then the O would seem as if it has a charge of what? You see that 1 right there? There's an imaginary 1. Do you see it? So then you're like, okay, 1 minus. But then you're like, I've never put a 1 minus with an oxygen. True? What is oxygen's charge? It is a 2 minus. So I have reduced this compound in this final version from what? It truly, before I reduced, it was a 2 minus here, which is the true charge of oxygen. So that means if I double this one, I double this one. So this was truly a 6. So then this would be iron. How do I write 6? Bi. And then how do I name the tail end of this? It's oxygen, so I change it to oxide. So be careful in those ones that have been already reduced so that you're remembering. You should go back and always reconsider if that's the true charge. Yeah.
How did you know that the charge of oxygen was negative?
Because it's when you, well, first off, the cations are always listed first in a compound formula. The anions or the negative charges are always listed second. Also, oxygen's in group 6, and so it's going to gain 2 electrons to look like neon's electron configuration. So it gaining 2 electrons means it absolutely, without a doubt, has a negative charge. There is no option. Yeah.
For the previous question, could we like simplify our answer?
Yes, you always should simplify your answer. If it's the charges that are reducing, don't reduce any of those. Like, give me an example. Do you have one example that you want to go over? Like,
14A
where do you see that? That's it. If it's a polyatomic ion, don't touch it. It's a happy family. Don't be a homewrecker. It needs to stay together. It itself is a thing. Don't reduce itself. Reduce the charges only. Okay, so I'll find one for you in a second. All right, back here. Let's go ahead and name. First off, identify. What is this? Ionic or covalent? Okay, it's covalent. You read it and you say exactly what you see, except you're using prefixes now, right? So nitrogen dioxide to say that there are 2 oxygens. Yes.
So now it's not already like switched, like the 2 goes to.
You only switch charges. So if I'm saying you only switch charges, charges are ionic charges, yes? So charges, when I say the word charges, I'm telling you it's an ionic compound. These subscripts here, this 1 and this 2, are not charges because there's non-ionic compound. So we should not switch them. They are describing I have 1 nitrogen and 2 oxygens in my molecule because I'm now a covalent compound. So you're going to switch in your brains left and right as you come across these and you identify them as ionic or covalent. Yeah. Calcium, and you're recognizing that as a metal, right?
Yeah, and then there'd be sulfur,
How do I change sulfur's ending if it's just a plain old?
it would be I.
Right, so sulfide. Not sulfuride, I almost put sulfide. Sulfide. And if you mess up on spelling, we'll get over that eventually. Anything else there?
And
That's it. Yes. If it's a metal and a non-metal, you name it the metal by its first name, the anion by its true name, but you change the ending to I. Yeah.
Actually, about to write about that would have previously been calcium phosphate.
Calcium, those are 2 there. Calcium, I don't know if you can imagine typing subscript superscript, and it takes a little time, so I may or may not have a typo. I try to fix them as I see them. Okay, so calcium phosphate, because that's P of 4, not phosphide, because it's not just straight P. Okay, go ahead and do, I don't know, this one, KOH. What's the first name? Potassium. And then your job here is to recognize there is a last name, not 2 last names, a last name. If potassium is the first name, right? OH is the second name, and you're going hydroxide, right? Well, if you say hydroxide, what does it sound like you're saying? Hydrogen and oxygen, but we don't put O, we put O, okay? Please do not put HO on your paper. Hydroxide. You will do it, and I will say, don't you remember? And you'll be like, oh yeah, okay. Next one, yeah.
if that last one was KOH, would that be
That would be ternary because it has 3 types of elements involved. Okay? Let's do a couple more here, and then I think we're going to rest on this for a little bit. How about this one? What's the first name? Sodium. And then, so if you're saying it's a metal, right? So if it's a metal, it must be ionic. Ionics always have first name, last name. So then the second name is this big honk right here. Say again? Chlorate. Right. Chlorate. Because you recognize it as a polyatomic, and I have it right here. Okay, how about down here? I'm trying to get all your questions I possibly can right now. How many more questions are here? Sorry. Okay.
PBSO4.
PB. Where do you see that? Oh, PBSO4. Okay. So first name is what? Lead. Without a doubt, it's lead, right? So that PB right there is the first name. The second name you're saying is sulfate. I'm leaving a gap there for a reason, okay? This is a transition metal. It looks like its charge is what, according to how the formula is written? It looks like it's 4, but really we know that 4 is not a charge. The 4 is a part of, so PB has a charge, right? Sulfate. This is a big happy family. Again, don't be a homewrecker. Don't consider that 4 to be part of lead. It is a part of sulfate itself. What's the charge of sulfate? Always. Say again? 2 minus. If sulfate has a 2 minus charge, that 2 truly would have gone down here, right? Okay? But you can see that they both reduced to 1s. So if that sulfate had a 2, what does that lead also have to have? A 2 as well. So that would have been Pb2SO4 2, but then those 2's must be reduced. So that automatically tells you lead's charge is 2, so then you indicate that in the formula by telling me transition metal charge of 2. Anything else right here that you guys can see on the board? Yeah. Do you see the thing down here? I'm getting there in just a second, okay? I will do this one because it's a weirdo. Yeah. Because sulfate. So the thing is, if I know, I'm trying to think of a good example of this. Gosh, I can't think of a good example. So if it has a standard charge, you know the charge, I know the charge. We don't have to say it. So no one has to say it out loud. No one has to write it out loud. We know it's there, so we implement it in the formula, but we don't show it. But if it has a variable charge, like lead could be 2 plus or 4 plus, I have to say it because you're like, oh, she said lead, did she mean this one or this one? If there's a question about the charge, then you put it. But if it's not a questionable charge, everyone knows it, so we don't put it. I'm trying to think of an example in real life for that, and I can't think right now. Yeah.
The one is like COSO4 6H.
Okay, I'm gonna go ahead and do this one now. So CO is who? Cobalt. So cobalt, transition metal or not? Look at where it is. It is a transition metal, so do I need to put a Roman numeral? Absolutely. I'm going to go ahead and put parentheses there, and I'll put that there in a second. So then I see cobalt, and then I see SO4. Well, who's SO4? Sulfate. Our old friend sulfate has a charge of 2, and if you don't see the 2's here, what does that mean that happened? They cancel each other out, or they reduce, so what does that tell you cobalt's charge is? 2 as well. They both reduced down to 1 and 1, and previously sulfate had a 2, it must be 2 and 2. So then cobalt's charge is a 2. That's brought by the process of elimination by looking at the formula. Then you got this guy who's just along for the ride, okay? This is a compound that has water embedded in the compound. Do not multiply it. This dot is just saying, I'm a part of this. I'm a part of it. I'm like connected to it. I'm not multiplied by it because that's like, doesn't make sense of a compound, right? I'm multiplied by water. Okay, so then you just put cobalt 2 sulfate. How do you say 6 in prefix names? Hexa. And how do you say that you drink a lot of water? You feel very hydrated, right? So water hydrates a compound. Hexahydrate. We're now, that's a blend of like ionic compound and a covalent compound, but it's a special type called a hydrate. And that's the only reason we're implementing that prefix. It's just because I need to say how many hydrates I have, how many waters I have. Yeah.
So anytime there's a transition, we'll use a Roman numeral.
95% of the time. When do I not use the Roman numeral? No. So you said anytime there's a transition metal, all transition metals have Roman numerals except for the ones that have the standard charges, which are which ones, Chloe? Zinc has a 2 plus. One's right under zinc. Look right under zinc. Cadmium has a 2 plus. And then my favorite, silver's number. Oh, silver's number 1. Okay, so silver's number 1. That's how I'm going to always do it because silver's way better than gold. And those are always the ones that have a standard charge, meaning we don't have to write their transition metal. Yeah.
So if you were going backwards with one that is multiplied like that,
Mhm.
how would you know that it was multiplied because there's 3 names?
you would know it's you would know that there's a dot there. I'm not even going to say the word multiplied. I would see it's a hydrate. If it's a hydrate, it has the standard system of naming. Name it and then go stop blank hydrate. So the blank hydrate, so the number of hydrates goes second. So I'll do another example of that. So what if I have copper to phosphate decahydrate? You guys write the formula down for that. Do this part first. Copper to phosphate decahydrate. And we're gonna have to move on to acid and orgo in just in like 1 minute. So I'm hoping that answered enough questions here for you. Kyle, show me what you got. Tell me how you started. 1 second.
I started with the copper to phosphate.
Okay.
So I did Cu and then PO4.
Okay, so hon, tell me the whole thought process. Yeah.
The charge of copper is 2 volts,
Okay.
and then phosphate is PO4, which starts with 2 minus.
Not quite.
No, 3 minus.
3 minus. Okay. So those are its charges, and then what?
You cross the
Okay. So then what did you get?
so it's Cu3 and then PO4 parentheses 2.
Okay. Pause there. Everybody got me here? Question, Caroline?
No.
Question, Lindsay? You good? Okay. Ayana, what do you think I do with the rest of this? Deca means 10, and this is where I have the hydrate, right? So I put that, not a multiplication mark, I put a dot. Okay, dot, how many waters? 10 waters. That's it. And so if you name that, you would name it copper to phosphate decahydrate. Okay. I need to get one more question. I think Caroline, do you have a question on the ones I didn't do yet down here?
No.
Okay. I'm gonna pause on this. Let's jump on acids. Okay. Acids. Go ahead. Maybe we can do a quick jump up and run because I have some papers I need to pass out. I need to pass these out to everyone. And we're gonna talk about problem set 7-8 as well. So can everybody look and see where everybody's sitting right now? You need to get up because I've been talking for like a good healthy 45 minutes. Okay. I'm gonna pass out a couple papers over and you guys help pass this out to the group. Okay, glad we could agree on that. Okay, perfect. Good. Go ahead, the other people are sitting. I'll pass these papers out. There's a bundle of papers coming to you. You can help pass out. The whole group can help. The whole group. The whole group can help. Come on, help the group pass out. Can I give you this one? Oh, pass. We can go really fast. Yeah. If somebody's not here, put them here on the table. Take like 3 minutes and I'll be back to you. Just kind of throw them in the general area. They'll figure it out. Lindsay? Yes. Oh, should I help each other? All right. I don't know where anybody sits. If you don't know, please just give to me. Hi, over here. They're already sitting. Even if you just have to get to the front of that letter, you might find that sitting.
I'm just looking at the Caleb. Yo, you want some papers?
Where do you want to go? The ones that are not papers, must be back in the box. We go grab some papers from people. Guys, help each other. Help each other. Margaret, and I'll do Kyle, where do you sit? Okay. I mean, wait, sorry, that's the wrong one.
Oh, this is Caleb.
Oh, Carol. Thank you. Wait. That's for you. Way out. Leo, thank you. Bring that here for me. Once you get back to your seat, go ahead and start writing this information down, and then I'll tell you where we're going from there. Jacob sits right over there, where EJ's standing. I got you here. All right, guys. Hand me the papers in like 30 seconds if you can't find somebody or if you don't know where they are.
I know this person.
Here, Miles, I'll take the rest. Thank you.
It's like
Carson, how's the Sicilian? I'm gonna tell you what's on your desk right now. Here, we'll go over this. So what's on your desk? Two things I think you should note. The Scantron that you have is your multiple choice from Unit 2. You must have that so you can complete your required corrections on Unit 2. And that's what I have on the board. You can see it over there in blue. Field B tomorrow, Tuesday. Those of you who have asked, I've said, hey, you need to make 35 points on the free response. You had to come. I really want to highlight tomorrow free response. So if you know you also need to come on free response, you can still come Tuesday. But what I'm doing on Wednesday, B, is I'm going to be helping people with Unit 2 multiple choice and free response. And I'll try to help everybody, but you also can sit in groups and help each other out as well. You'll notice that on the multiple choice, the check marks are not, those mean you went incorrect. We notice how these words on the Scantron. Yes, again, there's real done, but it's trouble. Additionally, you have problem set 7, 8. My goal is hopefully to go over problem set 7, 8 with you at the end. Because I was not happy with the quest from Friday, the molecular modeling section. So I'm going to embed that again on the next assessment, like summative assessment that you guys take with me. So I'm going to review that with you in terms of problem set 7, 8, because I feel like that was a pretty good representation of what was expected, but problem set 7, 8 wasn't all that pretty, so I'd like to review that with you. So my goal is to do that with you at the end of class, after we do acid nomenclature and organic nomenclature. It should take us about 20 minutes, so I need your wholehearted attention for 20 minutes after I start here. So right now, thank you for listening. You're writing down what's on the board, which is the acid nomenclature system. It's not. Okay, so as you're writing down from this, I'm just explaining to respect our time. So my goal is to not spend 45 minutes on problem set 9, but hey, whatever works, right? So now we have acids. Now the acids are really their own separate category of nomenclature. acids will always tell you they're an acid because they have an H, acidic hydrogen, an H1 plus in the front of their compound. Now the plus, like Lindsay said, the superscripts don't exist anymore once they're in the compound formula. So who's ever heard of hydrochloric acid? Okay, how do you know it's an acid? Because it says acid, right? Every single acid will say acid, so it's a dead giveaway to them. And hydrochloric acid, its formula is HCl. And so what you see from a formula standpoint is that the acidic hydrogen is in the front of the formula, like the standard way of writing these formulas will always be. So this information up front is actually about binary acids. And so the binary term is kind of coming back into it one more time. What does binary mean? 2 elements, okay? And if binary means 2 elements, then what we have here is we already know the first element. Because like I said, acids always have what in the front? A hydrogen. Now your job is to figure out what the second element is. But the second element is so easy because it says it in the formula. So for example, if I say hydrochloric acid, you see the chloric, right? Well, what does chloric kind of sound like? Chlorine. So then what I did here, and this is how I got the HCl formula, was I said, okay, acids have an H plus. H plus. Chloric is chlorine, but what is chlorine's charge from the periodic table? Look on your periodic table and tell me where chlorine is. 1 minus charge, because it's in the 7th group. So plus 1 and plus minus, these, now, however, the fact that they're acids, they act ionically. They have charges, and you can see that charge from here, and you can also see it from the chlorine, and so when we crisscross these charges, they do make a 1 and 1, which is HCl. So just focus on the binary just for a moment with me. So that's all of this right here. Now, what you're going to hear, I want you to tell me the trend that you're hearing as I say a couple of these, which is actually on your paper in front of you. I'll give you like 5 more seconds to write down what you're writing. So on the paper in front of you, actually I copied it upside down on purpose so you would know we're only focusing on this tiny chart up here in the corner. The rest of the paper on the back is stuff for like later in the week. Ignore the stuff in the back. And like I said, I copied you about 50 other practice questions if you want them for your own purposes for success. So looking at the top section up here, where it says 1 through 15. 1 through 15, you have some hydroblankic acids. So the very first one you see, do you see hydro in that one? That nitric acid one? No. Okay, so this is the rule of thumb. If you see hydro, it does not mean H. Every acid has H, right? That can't be the qualifier. If I see the word acid, that's when I'm like, oh, it's got an H plus. Hydro means it's binary. So hydro is the key giveaway to tell you it's a binary acid which has an element and one other element combined. So let's look at all the hydro examples on acid nomenclature worksheet in front of you, 1 through 15. And let's approach them just like this. So the first one you see is what? The first one you see that has hydro is what? Bromic acid. Let me see if I have the sheet. Here it is. So hydrobromic acid. Okay, so here we go. I'm going to walk through the step-by-step process. If I see hydro, I know it means what? Please do not say hydrogen. Binary. It means it's NH with one other element. Well, what's the other element here? Bromine. Bromine, right? So hydro means there's a H1, I'm sorry, hydro means it's binary, which means it's H with, H plus with, bromic is bromine. What's bromine's charge? 1 minus, so H1 plus, Br1 minus, crisscross, what do you get? HBr. Because it's a 1 and a 1. Yes?
You just said
Hydro absolutely doesn't mean H. The fact that it's an acid means it has an H. So I'm trying to get you away from thinking hydro means hydrogen, because it does in like a polyatomic ion, but not this. Hydro is telling you it's a binary compound, meaning it has an H plus with one other thing.
So one's on the right would not be like because they're not binary. 'Cause 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 they're not binary. 'Cause
There's a mixture actually. There's some binary ones and some ternary ones here. I haven't even gone over how to rename ternaries. But for example, 16 through 30, put a little mark next to ones that are binary, meaning 2 elements involved. 1 second, Rishi. Tell me when you see one. 18 is a binary compound. Okay, keep going. 21 is binary. 23. 30. Okay, so we're going to name those in a second. I'll hit that in a second. Rishi, wait. Okay, next one over here, 1 through 15. Which one's binary? 7 is binary. Hydrochloric acid means what's the nonmetal involved? So chlorine, chloric comes from chlorine, so that's H1 plus again. Chlorine's charge. Say again. 1 minus, put those together, what do you get? HCl, 1 and 1, right? We don't write the 1s because they look stupid. Okay, through 15, what's next? Hydrofluoric acid. So I'm doing all the binary ones here in green. Hydrofluoric. What's the nonmetal involved? Fluorine. So hydrofluoric has an F with a charge of 1 minus. These are all in group 7, right? So this makes it very easy. So then put that together and you get HF. Okay? We got 2 more, I think. 1 more. Number 12, hydroiodic. What's the nonmetal involved? Iodine. So that's H1 plus with iodine, which is I charge. 1 minus again, crisscross 1 and 1, HI. Hi. And that's it for the hydros, right? That's all the binary ones on this side, meaning 2 elements. So, since Darcy wants to, and I want to as well, let's go ahead and write the names now based on the combination of elements. But we're only doing 18, 21, 23, and 30 for the moment. Yes? Is it related to what I'm doing right now? Oh, my bad, my bad. Pass this over here to Rishi. Sorry about that. Okay, so back to 18. You see it's binary, right? You've seen H and Cl. How do you tell me it's binary? Hold on, how do you say it's binary? Hydro. Thank you. You're picking up what I'm putting down. So all of these are going to start with hydro. All of them. Hydro, 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 hydro. Because you're telling me, that's how you tell me it's binary. And you're like, it's an acid in low. I know it's got an H plus. If you say acid, I know it has an H plus. I'll answer in a second. Okay. So you guys fill in the blanks for each of these, and then put ic acid at the end. Should take about a minute. Never mind. Okay, I know. I do. I know too. Thank you. Bye. I'll do this in a second. Priorities. Okay. Suraj, first one. Hydro what? Chlor, but how do I change the name? Chlor. It's a major group. Help out. Chloric acid. Okay. Emily, next one. Hydro. Iodine is iodic acid. Darcy's group. Hydrofluoric acid. And then Chloe's group up here. Next one, 30. Hydrobromic acid. So all of these binary ones always start with hydro and end with ic acid. It's just you gotta fill in that little middle name, okay? And the middle name is based on the non-metal it's combined with. Okay, let's do another type. So here we go. Yes.
What compounds are acids considered?
They're molecular compounds, however, they act ionic. Work with me here. They're molecular compounds, but they act ionic. They are truly molecular compounds because they're all generally non-metal. But they act ionic because they're so different in their electronegativity, they actually end up taking electrons. Alright, ternary in blue here, okay? Ternary acids, you can guess, ternary means has more than 2, right? So ternary, just like our previous with our polyatomics involved, more than 2 elements. I'll now give you a second to catch up with me. with the systems up here, and I'm going to take attendance. So if hydrogen's taking one place, you can't have a polyatomic ion involved. Therefore, that's why they come in second here. And I will tell you the way that I found it easiest to memorize this system of how you change their last names. If I'm a polyatomic ion that ends in 8, like it says here, drop it and go to ic acid. Well, that looks really similar to the first style, right? And then the ites get changed to os acid. So here's how I remember it. Ic, I ate too much. Ic and ate go together. Ic, I ate too much. Okay, deal with me. This is how I remember things. I have to come up with the stupidest way possible. Okay, and then I have tendinitis. I have tendinitis. Itiness go together, and ic, I ate too much go together. If you can come up with something better than that, you let me know. But right now, that's how I'm going to keep referring to help you remember the name change at the end. Okay, so does this one, guys, does this one have an H in the front?
Well, yes.
Yes, I said that in that manner because it's an acid. It has to have an H in the front. Does it say hydro? No. So does hydro mean H? No. Hydro means binary. You guys are awesome. Okay, so let's go to these examples we ignored here. So we had chloric acid. Okay, we know it has what in the front? It has a H in the front. Thank you. It's an acid, right? H1 plus. I'm sorry, I totally missed nitric. My bad. Nitric acid. Nitric acid. Nitric came from nitrate. Look at your polyatomic ion. Listen until you're comfortable with them. What is nitrate? NO3, 1 minus. Okay, so I'm writing the charges out, and then your job is to crisscross them. What's the overall formula? HNO3. Good. Ic came from 8. You with me? Yes.
Oh, H&O.
Yes, yes. Because it's an acid and it always has an H plus. An acid always has an H plus. Always. Never without. All right, next one. 2. Chloric came from chlorate. Okay, so what's in the front? H1 plus. Chlorate is what? ClO3 charge. 1 minus, crisscross, what do you get? HClO3. Good. Acetic acid came from acetate. Okay, acetate. So there's H plus is still here. What's acetate? C2H3O2. Charge 1 minus. Put those together by crisscrossing. HC2H3O2. Leave that H in the front because that's screaming to me I'm an acid, so I like to make sure you know it's an acid. Let's go ahead down to number 5. Now we see that our first os. Os came from ite, right? So sulfurous came from sulfite. Now the name that little like sulfurous and sulfite, they don't sound as much similar as they should, but that's just how the name works. So sulfurous came from sulfite. So I'm gonna write our H plus like we have been. What is sulfite? SO3 2 minus, right? And if you didn't remember sulfite, you remembered sulfate, SO4 2 minus. So then for your SO4, you drop it down in oxygen, and that's where we got sulfite. So remember your eights. Your ites will fall into place. So that's SO3, as Rishi said. Charge 2 minus. And what do you get when you crisscross those charges? H2SO3. Good job, guys. Okay, I'm going to leave you alone. I want you guys to finish the rest of these, and then also do your names on this side. That way you're not doing these at home and you have a good sample of them to work from. If I have to push organic another day, I can totally do that. Let me see. help each other out in your groups too. I'm gonna help by writing answers on the board, but you guys talk to each other. I feel the pain. I remember when I had to memorize the polyatomic ions too. So, trust me, it's going to take you about a solid week of looking at them every single day to feel comfortable. So make sure you're looking at them every single day. Keep doing it on your paper and just check at the end. Coming. All right, after you finish these and after you feel comfortable with acids, I want you to get your problem set and finish your acids. And then we'll try to review like 1 or 2 problems. Yes, Chloe. You good? Oh, don't pack up yet. I still got 7 minutes left. Don't you waste my time. If you're going to pack up, I'm going over problem set 7-8, which I need to in about a minute.
1 second. Chloe, what's up?
Does the H the acid count as one of the elements?
Yes. Yes.
So,
Alright, if you don't mind, finish that last one you're on. I need to review 1 or 2 examples from problem set 7-8. So have problem set 7-8 in front of you. And what you'll notice is that I gave you effort credit, like 10 out of 10. If something wasn't complete or it was like absolutely slaughtered, did not give you 10 out of 10. So I tried to give you effort credit because, you know, chemistry, it takes a practice. And if I stop reinforcing your practice, you stop practicing. Just like to get good at anything, a sport, you practice. And chemistry is basically a sport. So if you guys want to be Chem Olympians, then here we go. So first thing I want to go ahead and recognize is on your chart, some of you guys did very well with identifying ionic and covalent, and some of you guys need some help with that. So on this year's 1 through 10 on the chart, I don't have the chart here, but I have the elements. Let's go ahead and talk about which ones are ionic, based on the fact that you know ionic ones are made up of what and what? Metal and non-metal, right? So go ahead and categorize these. 1, SRF2, look at your periodic table. Where is SR? You shouldn't be looking at me. You should be looking at the periodic table. SR is in group 2, so it's a metal, true? Yes? Okay. If I'm a metal, what am I probably going to be here? An ionic or covalent compound? Ionic, right? So metal, non-metal. Which other ones are ionic? Go ahead. Which one? Number 3, NaCl is a metal, non-metal. Which other one? 7 is Na and Na2O. Those are the 3 ionic ones. They have a very, very distinct way of drawing their Lewis dot models, right? And so this is where we struggled. We were drawing a lot of our ionic ones with a bonded pair. So if I'm holding Caleb's hand, we're sharing 2 electrons. That means we're covalent. We can't bond like that if we're ionic. We have to do that little switcheroo of the electrons. So SRF2 is my first one I'm going to draw. SRF2. I see it's ionic, and if I know it's ionic, and you guys even wrote down it was ionic, and you still drew it covalently, that means you're not connecting the 2 words in the drawings, all these different depictions of a compound. If it's ionic, you must show ions. Well, how do I show ions? SR starts out with how many valence electrons? Draw this with me if it was incorrect, because you will be correcting this entire problem set, resubmitting it to me. If I'm doing it now, you better be doing it now with me. How many valence electrons? 2. How many? So now I have 2 fluorines, right? 2 fluorines. I'm just going to draw them separately. That's cool. Draw 2 of them. How many valence electrons? 7. So 2, 4, 6, 8, 7. 2, 4, 6, 7. 2, 4, 6, 7. I have 7 there. What happens to form an ionic bond? Say again? Transfer electrons. Do not say share. I know if I gave you a cookie, you're like, oh, Ms. Inlow, share a cookie with me. But that's totally, I'm giving you a cookie. That's not necessarily sharing in the covalent sense. So this electron gets transferred to fluorine, and this electron gets transferred to fluorine. That transfer means I no longer have them, so what's my charge? +2. And you now know that because that's the group 2 charge. Each of these fluorines separately have now 8 valence electrons. So if this fluorine gained 1 electron, what's its charge? 1 minus, or -1. But there happens to be 2 of them, so I put the 2 subscript down there. And that's just showing I have 2 of them. Do not put there's a 2 negative charge there, because that's a lie. Fluorine can't gain 2 electrons. Fluorine gains 1 electron, yes. And that's okay too, if you want to write it like this, SR2+, and then 2 fluorines like this. That's also fine. Just don't put a 2 negative charge, because itself is not a 2 negative charge. It is a 1 negative charge. So that's one of the ions. Second, you guys can do the 2 other ions because you know the flow now. The second one I want to correct with you is COCl2, and that's number 5 and 6 are very similar. And so a lot of you guys were not having octet on your compounds, within your compound. And carbon will always be the central molecule or central atom. So COCl2. COCl2. Very first step you must do is count your valence electrons. Count them up real quickly for me. C has how many? Quick. Valence electrons, 4 valence electrons, plus how many from oxygen? 6 valence electrons, plus 2 fluorines with each what? 7. Okay? 7, 14, 20, 24 valence electrons total in our structure. Who's in the center? Carbon's in the center. Who has to be attached? Oxygen and chlorine and chlorine, right? So it doesn't necessarily where you write them, it doesn't matter. It just means to be generally symmetrical. Currently, I have 6 electrons on, 6 valence electrons on my structure. I have 18 to go. So what would I do next? So give everybody dots. 2, 4, 6, 2, 4, 6, 2, 4, 6. And then carbon, some of you guys did this, right? How many electrons are here? 26, 8, 16, 24, 26. I can't have 26, so what do I do to make them get down 2 electrons? I make a double bond. And yes, I need to make it symmetrical, right? So I'm going to take away the electron limb pair from oxygen and make a double bond between them, because I can't make a double bond on chlorine and not the other chlorine. Again, that symmetry helps make the decision on where to go for the double bond. So the double bond should exist here. That means 2, 4, 6, 8 carbon's got octet, and 2, 4, 6, 8 oxygen's got octet. You'll see that very similar in the other example. Wait 1 second. You guys need to correct that problem set 7, 8 by Friday. Okay? I want it back by Friday. That means ask questions. There's a lot on there that you guys didn't even read. You need to finish that for yourself. Yeah. Oh, yeah. I don't know if I have any more. I gave you that. I gave you that.
Oh, I brought back.
I know, I gave you the box. I don't know if I have. Lindsay, clean this up later. We'll clean this up later. Okay. Yeah. Oh, no. Yes. This is actually we were still after school. It was exactly this. Exactly the same, except you have a prettier close. So what I'm gonna do is I'm gonna have him review his. I need to know who did it.
I did it. Okay. I like came up with this stuff, but like, I mean, we did, it was like,
I mean, his was
Both of
like
us
literally
did it.
verbal. So next time what I need from you is need to know. You guys need to have some original work. Okay, so I'm not going to give you this 50. I need to talk to you. So you look at somebody, make sure that you're like, hey, come over, what can I do for you? Okay, so give your points back, but don't have verbatim stuff with each other. Hey, Chloe.
hey, what was this?
Wait, I'll get